So let's move to our next keynote profile, Dr. Ratna Kumar Jambi, Principal Genba Sampanra Mose College of Engineering, Balewadi, Pune. Dr. Jambi is a distinguished academic leader with extensive experience in engineering education, strong expert in artificial intelligence, machine learning, and deep learning. His today's topic is Introduction to Artificial Intelligence, Machine Learning, and Deep Learning. Let's warmly welcome Dr. Jambi.
Hello, good morning, good afternoon, good evening, everybody. I am Dr. Jambi Ratna Kumar, Principal of GS Mose College of Engineering, Pune, India. Today, I would like to thank conference convener for giving me this opportunity. Today, I am going to give lecture on artificial intelligence, machine learning, and deep learning. So, first of all, what is the artificial intelligence? So, artificial intelligence application is able to perform its own task without human intervention. For example, OTT platform you can take. Netflix is there. If you watch any action movie, so after completion of movie, it observes your behavior. You are showing interest on action movie, then it will recommend all action movies. Suppose if you watch comedy movie, so then you are showing interest on comedy, so it observe your behavior as a comedy, and then it will recommend all comedy movies. So second example is, suppose if you are going for purchasing any product in online, suppose if you have purchased any cell phone, then you are in need of iPod or headphones. So then it will recommend headphones and iPods. So third one is Tesla self-car driving automatically. See, it observes the behavior of the road and where it has to slow down, where it has to increase the speed. It observes automatically, it drives automatically by using artificial intelligence. So these are the examples of artificial intelligence. Next, we will go for machine learning. Machine learning is subset of artificial intelligence. It provides the statistical tools to explore the data and analyze the data. It means it works on the labeled data. See, machine learning is again divided into three types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning means it works on the labeled data. Labeled data means, for example, height and weight we are giving and we are feeding as if he will comes under fit category or obese category. So based on that, we are feeding all members details. So suppose any new person is coming, we are entering his height and weight. So based on previous data, we are concluding that whether he will comes under obese category or fit category. So this supervised learning again divided into two categories. One is classification, another one is regression. Classification is so output, it produces the output as a discrete values. So suppose in this classification, binary classification is there, multi-class classification is there. Binary classification means if you are dividing into two classes. For example, you are purchasing one product online. So suppose I have purchased one product on toothpaste. I have liked it very much. Then I have given rating as 5. Same thing product my friend also purchased. He didn't like that product. Then he has given only 2-star rating. So like that, many customers are giving ratings. So whatever I have given rating, that will comes under positive review, and my friend whatever he has given, that will comes under negative review. So less than 50%, whatever the rating you are getting, that will comes under negative review. More than 50% means more than 2.5, you are getting rating comes under positive review. So that is called as the binary classification. Multi-class classification means, suppose you are storing the data, cat images and monkey images, lion images, elephant images. So here we are using multiple classes. From this, you are giving any one image From that, you are concluding that whether it is a cat, whether it is a monkey, or whether it is elephant, like that. So that is the classification. Next, regression. Output of the variable, it is continuous variable. So for example, if you want to purchase any house, suppose in Pune city, 500 square meter house cost is 50 lakhs. So like that, I am storing all the data. Suppose what is the price of 1000 square meters. So 500 square meters cost is 50 lakhs. Then 1000 square meter, automatically we are calculating it as 1 crore. So like that, we are predicting the regression. So output of the variable is discrete variable. Next, unsupervised learning. Unsupervised learning is, see, unsupervised, here we are not getting any label data. So based on similarity of data, we are partitioning into clusters. So for example, songs are there. Songs, there are different songs are there. Here we are partitioning into classical songs, hip hop songs, rock songs, and devotional songs. So based on similarity of data, we are dividing into different groups of songs. So in this unsupervised learning, there are different of algorithms are there. First one is K-means algorithm. K-means algorithm, suppose first we have to assume that based on data points, how many clusters we have to make. So in this case, I am assuming that we want to create 3 clusters. So first we have to identify 3 centroids. So first here is, first 3 objects data points I am taking, 22, 9 and 12 are the centroids. Next, we have to find the distance from each data point to centroid point. So suppose 22 is nearest to 22, so we have to keep in 22 cluster, and 9 is nearest to 9, 12 is nearest to 12, 15 is nearest to 12, so we have to keep in cluster 3. So it is nearest to centroid 12. Next, 10 is nearest to second cluster, that is 9 centroid. So that's why we are keeping in second cluster. So next, 27 is nearest to 22. So that's why we are keeping in cluster 1. Next, 35 is nearest to 22. 18 also nearest to 22. Next, 36 also nearest to 22. So we are keeping in all in 22 centroid cluster. Next, 11 is nearest to 12. So that's why we are keeping in cluster 3. Now again we have to find out the centroid. How we have to find out the centroid? See, we have to take average of all these objects. 22 plus 27 plus 35 plus 18 plus 36 by how many objects are there? 5 objects are there. That value is 27.6. Next, 9 plus 10 by 2. 2 values are there, that is 9.5. 12 plus 15 plus 11 by 3, 12.66. Now again we have to take these 3 values, 27.6, 9.5, 12.66 as the centroid. Again we have to find the distance from data points to all these centroids. So which one is having a minimum distance, we have to keep in the corresponding cluster. So that's like this. Again we have found this. Next, we are getting 22, 27, 35, 36 in one cluster. 9, 10, 11 is another cluster. 12, 15, 18 is in another cluster. Now again, we have to find the average. 22 plus 27 plus 35 plus 36 by 4, that is 30. 9 plus 10 plus 11 by 3, that is 10. 12 plus 15 plus 18 by 3, that is 15. Like this, we have to repeat this procedure until we get centroid values are same. So if you get the same values, then we have to stop that these clusters are formed. So here 30, 10.5, 16.5, 2 times repeated. Here we have to stop and 3 clusters are formed. So next one is in unsupervised learning. Another one is, that is hierarchical cluster. So we build the We build the hierarchy of cluster based on bottom-up approach, that is agglomerative method, and top-down approach. Bottom-up approach means here we start with each data point with its own cluster. So each cluster is having each data point is in its own cluster. First, we have to merge one cluster with another cluster which is having nearest. For example, A, B, C, D, E. 5 clusters I have taken. A and B are near. So we are making A and B is one cluster. C and D are another nearest clusters. So we are making C and D are another cluster. Suppose E is nearest to C and D. Then we are making CD is as one cluster. Now again we are merging AB and CDE and we are making one single cluster. That is called as the agglomerative method. That is also called as bottom-up approach. Next, top-down approach means first all data points are in single cluster. That means A, B, C, D, E all are in single cluster. Again we are dividing into smaller clusters. Suppose A, B, C, D, E is there. That we are dividing into A, B into one cluster, C, D into another cluster, E into another cluster. Now again A, B again we are dividing into A and B is different clusters. C and D again we are C, D again we are making into C and D separate. Again E is in separate. So now individual data points are in its own clusters. That is top-down approach. Next, the third point is DB scan clustering. DB scan clustering means density-based spatial clustering of application with noise. So here we have to identify what is the density. Based on density, we are dividing into clusters. How we are dividing? We are finding value. So suppose one point is there. From that point, we are finding the distance. From some center point to some distance, we are making one radius. Within the radius, at least we should have minimum 3 points. Then we can call it as core point. If we don't have minimum 3 points, then we cannot call it as core point. So suppose only 2 points are there within the circle. Whether that point is having association with the core point or not. So if it is having association with the core point, then again we are keeping in the circle. Suppose only one point is there in the circle, then we can call it as noise point. So then we have to avoid, we have to detect the outlier and we have to remove that. So that is called as the, so what is the purpose of this DB scan clustering is, it is effective at identifying and removing the noise in the data sets. Next, third one is reinforcement learning. So in this reinforcement learning, so first agent is there, environment is there, agent is performing some activity, some action. If it is true, then he will give reward point. Okay, otherwise he will not give the reward point. So here, best example I can say, suppose if you want to train your pet dog, so you are throwing ball to some direction and you are asking dog that bring the ball back to you. So first attempt, if it is failed, it will not get any reward. Okay, if he achieves the task, then he will get the award. So here intention is you should get the maximum awards. So suppose if he has not achieved the task, what we have to do? So we have to rectify the problem and we have to try to achieve the task. Second one is, suppose second example is, suppose small baby is there. You are teaching him how to walk. First day he will fall down 3 times. He will not get any rewards. So second day he will fall down only 2 times. So you will get one reward. So third day you will achieve the task, you will start walking. So then you will get rewards. So means here we should get the maximum rewards. So that is called as the reinforcement learning. Next, third one is deep learning. Deep learning means, see, it is the mimic of human brain. How our human brain is working. Based on that, so scientists thought that can we make machine learning based on how our human brain is working. So in this, again, we are dividing into through artificial neural network and convolutional neural network and recurrent neural network. So artificial neural network means if the data is in table format. So for example, if you want to predict the what is the house prices in Pune, so table format, 500 square meters, this much rate is there. 1000 square meters, this much rate is there. And what about 2000 square meters? Like that, it is mentioned in the table format. Predicting the house prices comes under artificial neural network. Convolutional neural network means it works on the images. So face recognition, everything comes under uh, convolutional neural network. Next, recurrent neural network means it works on time series kind of data, sequence of data. So speech recognition and converting that language from one language to another language, speech, that is also comes under recurrent neural network. Next thing is data science. Data science means it applies mathematical tools on artificial intelligence, machine learning, deep learning by applying statistics, probability, linear algebra, and it will predict and it analyze the data. So that is the main aim of the data science. Data science, it will apply mathematical tools, statistics, probability, linear algebra, all these things on artificial intelligence, machine learning, and deep learning, and it will predict the data, it analyze the data. So that is the relationship between artificial intelligence, machine learning, and deep learning and data science. So thank you very much for giving me this opportunity.
Thank you so much, sir. If anyone has any question, they can raise their hand.
Okay, thank you very much. Hello, any questions are there?
No, sir.
Okay, thank you.